Okay. Write each logarithmic form in exponential equations. Oh, that doesn't look right. Sorry, let me turn the sound off. There we go. Okay. Write each logarithmic form in exponential form is what it should say, but that's okay. Okay, so start here at the base. 3 raised to the 4th power equals 81. So these first 4 are all like that. Base for ln is e, so e to the 3rd equals 20. Base for ln is e to the 18th equals x, and number 4, e to the negative 1.10 equals 1/3. So just rewriting an exponential form. Then the second section, we're going to go the other way. So I'm going to write log, start here, 9 of 27 equals 3/2. Now this one, because it's an e, we're going to write natural log. I know some of you put the e here, that's fine. 8 equals 2.08. Same thing with number 7, natural log e 1097 equals 7. And number 8, log 5, 0.2 equals -1. All right, simplify. So you can do, if you forget how to do these, you can do them in your calculator, log 1/8 divided by log 4. Or you can set it equal to x, 4 to what power equals 1/8. So I would bring that 8 up. Now this is an exponential. You know how to solve this. Change both bases to 2. So 2 squared and 2 cubed. We cross them out. 2x equals -3. And divide by 2. So x equals -3/2. Number 10, the base is e, so these are the same, so this whole thing equals 6. Number 11, the 3's are the same, so this whole thing equals x. Number 12, I'm going to first bring this up to the top, so e to the -2. Now my bases are the same because this is e, this base is e, so this equals -2. Number 13, the base here is e. It's real small. There we go. So those are the same. So this whole thing equals 25x plus 8. And number 14, if we look at it separately here, if I bring the 3 up and I bring the 2 up, now I have e to the natural log x cubed plus e to the natural log x squared. The base is e here, so this whole thing equals x cubed. This whole thing equals x squared. And I can't add those together, so I'm just going to leave it like that. Express as a single logarithm. So just your basic log properties here. So addition is multiplication. So natural log 3 times 4. So natural log 12. Subtraction is division. So log 4, 40 divided by 5 is log 4, 8. It says simplify if possible. I would leave this one as natural log 12. This one you could simplify though. So if you set it equal to x, 4 to the x equals 8. You can make both sides a base of 2. So cross the 2's out. 2x equals 3. X equals 3/2. And number 17, bring up the 1/2. So natural log 7 minus natural log 9 to the 1/2. Which would be natural log 3, and subtraction is division, so 7 divided by 3. Number 18. Okay, so on these, on the first 4, I have x's on both sides of the equal sign. Oh, not this one. But if you have x's on both sides of the equal sign, you have to make the bases the same. So this one I can make 3 to the 3rd. Cross out my bases. 5x equals, oops. Oh yeah, 3 times 2x plus 7. So just solve for x. So distribute on the right. 5x equals 6x plus 21. Subtract the 6x would be -x equals 21. And divide by the negative. So -21. Number 19, I can make both of these a base of 6. Cross out the 6's. Distribute 2x plus 4 equals 4x. Subtract the 2x over and divide by 2. So x equals 2. And number 20, if you have a fraction, bring this up to the top. So 2 to the negative 1 to the 3x equals 8 to the 2. So I can change 8 to 2 to the third. Cross out the 2's. Negative 3x equals 6. Divide by negative 3, and you get negative 2. And 21. Okay, I worked 21. It's the same as the other 3. Made the bases the same and solve for x. Now, number 22, I cannot make the bases the same. So I have to take log of both sides. Remember, you have to put log in front of both of them. Move the 2x to the front. So then the first thing you want to do is divide by the log 8. So 2x equals, excuse me, make sure that you put the log in on the correct side. So log 3 divided by log 8. So 0.528. And I'm going to divide by 2. And I just do that in my calculator, so I'll just say divided by 2, 0.264. So x equals 0.264. Okay, number 23, so same thing. Actually, number 23 is different because the x is not in the exponent, so I'm not sure if that's a mistake, but we'll solve it. This is from a long time ago, though. Raise both sides to the 4/3. I'll double check the test and see if it's on there. So that crosses out. So x equals, and I just put that in my calculator, 40 raised to the 4/3. So 136.8. Okay, number 24. Subtract 4 first, so e to the 5x equals 11. Now, because I have e, instead of log, I'm going to take natural log of both sides. Move the 5x to the front. So 5x natural log e equals natural log 11. So same process as before. Divide by natural log e first. So 5x equals, I'm going to go natural log 11 divided by natural log e equals 2.398 and divide by 5. So x equals 0.48. Okay, number 25. We're going to multiply by 3 first. So that gets rid of the 3. So 4 to the 2 minus x equals 21. Now I can't make the bases the same, so I'm going to take log of both sides. Bring the 2 minus x in front. Divide by log 4, just like before. You're always going to want to get rid of that log first. So 2 minus x equals, put that in my calculator, we'll go with 2.2. So this is a positive 2. I'm going to subtract the 2. So negative x equals 0.2 and divide by negative 1. So x equals negative 0.2. 26, so I have natural log on one side. So I'm going to start with my base of e. E squared equals x. Put e squared in my calculator. X equals 7.39. 27, so I have a log on one side of the equation. So these two are going to be worked the same way. You have a log on one side of the equation, so 5 squared equals 2x plus 1. Leave this whole thing in parentheses. So 25 equals 2x plus 1, subtract 1, and divide by 2. So x equals 12. Same thing with 28. Start at the base. 2 to the 21st power equals x to the 7th. So to get rid of the 7, remember we do 7th root. So in your calculator you press math, number 5, and then you arrow back to delete that and just put a 7 in. And then I'm going to put 2 to the 21st. And I got 8. So x equals 8. 29, I have a log on both sides, but I have this number in front. We're going to bring that up as a power first. So log 7 x to the 3 over 2 equals log 7, 125. So cross out the log 7s. X to the 3 over 2 equals 125. So this is like that one on the other page. To get rid of the 3 over 2, we're going to flip it and do 2 over 3. So x equals 125 raised to the 2/3, which is 25. Okay, 30 and 31 are going to be the same way. So I've got 2 natural logs on one side and 1 on the other. Same thing here, 2 logs on one side, 1 on the other. Let's put these together first. So addition is multiplication. So I'm going to distribute the x. So x squared plus 4x equals natural log 21. Now I cross out the natural logs. X squared plus 4x equals 21. Subtract the 21 over and factor. So x equals -7 and x equals 3. Now remember, after a log can't be a negative, so this one won't work. Just x equals 3. So for log, on this one, subtraction is division. So I'm going to put these together first. So log A, x divided by x minus 5 equals log A, 6. Cross out the logs. X over x minus 5 equals 6. So we want to get this out of the denominator. So multiply x minus 5 over. So x equals, I'm going to distribute over here, 6x minus 30. Subtract the 6x over and divide by -5 will give you +6. Number 32, I'm going to subtract the 6 first. So that gives me 10, and then divide by this -10. So log 4 x minus 6 equals -1. So 4 to the -1 equals x minus 6. 4 to the -1 power is 0.25. And add 6, we get 6.25. And number 33, again, subtraction is division, so let's put these together. 48 divided by w. Log 8 crosses out. 48 over w equals 4. Multiply by w to get it out of the denominator. 48 equals 4w, and divide by 4. W equals 12. Tell whether the function shows growth or decay. So remember, inside the parentheses here, the thing being raised to the x, if it's bigger than 1, it's growth. Smaller than 1, it's decay. So 1.001 is bigger, so growth. 2 is bigger, growth. 10 over 11 is smaller than 1, so decay. And 1 divided by 0.2 is 5, so bigger than 1, so don't let that fool you. So that's still growth. Okay, 35. The value of a car depreciates according to the exponential decay formula. A car was purchased 5 years ago for $19,000, and the rate of depreciation is 15%. Write an exponential function to model the value of the car after t years. So A equals our original value. Well, here, let me write the formula over here. So I went with the minus because it's depreciating. So here's the original value of the car. 1 minus 0.15. Remember, we're going to move the decimal 2 places. Raised to the, it says after t years, so we're going to leave that as t. Then B says, what's the value of the car today to the nearest dollar? So 19,000 times 1 minus 0.15 to the 5th power. So now I'll actually do the math. Oops. So I put that all in my calculator, and I got A equals 8430.40, or 40 cents. Okay, it says when will the value of the car fall below 1,099? So let's put 1,098 here. Everything stays the same, and since it says when, I'm solving for t. So divide by 19,000 first. Oops. Actually, I'm just going to leave this as 99. I don't think that's going to affect anything. So I got 0.058 equals I went ahead and subtracted this 0.85 to the t. So take log of both sides, bring the t in front, and divide by log 0.85. So log 0.058 divided by log 0.85. So 17 and a half years. $36. 10 years ago, a collector paid $5,000 for an autograph painting. Today, it's worth $55,000. Find the annual rate of appreciation. So we're going to use 1 plus r to the t. So today it's worth $55,000. It started out as $5,000. We're going to find r, and it's 10 years ago. So the same as this last one we did, first divide by 5,000. So 55,000 divided by 5,000 equals 11. So 11 equals 1 plus r to the 10th. To get rid of the 10th, I'm going to do the 10th root in my calculator. So again, math, number 5, put in the 10. Oops. Try again. So I got 1.27 equals 1 plus r, subtract 1. So 0.27 equals r, and we'll make that a percent, so 27%. And the last one, Will bought his truck 4 years ago for $24,000. It's now worth $12,800. Find the annual rate of depreciation. So another rate 1, but this is depreciating, so it's going to be minus. So let's see, it's now worth $12,800. It was worth $24,000, so we're going to find r, and it's 4 years. So first thing, divide by 24,000. So 12,800 divided by 24,000. So 0.533 equals 1 minus r to the 4th. I want to take the 4th root of all that. So let's see, 4th root of 0.533. So I got 0.85 equals 1 minus r. Subtract 1 is negative 0.145 equals negative r, and divide by negative 1. So 0.145 equals r, or 14.5%. That's it, your last regular test review.